Hi, folks. This is the morning activity on May 17, and you are given this particular geometry, which happens to be from a previous midterm, and you are asked to use the most appropriate element, which in this case you must be using beam element, and use as many planes of symmetry as are needed to solve the problem. And the problem, the way it is these ends are clamped and this middle point is pushed down by some amount. Looking at this problem, you realize that uh, XZ is a plane of symmetry. So what you need to do for this problem is model only half of this geometry. Because it happens to be all in the same plane, I rather do it as a sketch instead of doing points in space and connecting them with lines, etc. And also notice that the cross-section of this bottom horizontal piece is different from the cross-section of the other four pieces. All right, just keep that in mind. So I go to CATIA. My units are already set properly, so I'm going to go to part. And immediately I save it. So file, save management, save as, desktop, a new folder. I'll call it morning activity. May 17. Okay. So everything is going to go in there. And we're going to make it. We can do this thing in the wireframe and surface design, or you can do it in part design, but at some point you have to come back to this workbench, wireframe and surface design, because you're going to join that sketch. So I'll stay here instead of going to part design right now. So on that vertical plane, I will sketch. Half of that geometry looks like this. We're going to put dimensions in a minute. So let's see now, this thing is 3 inches. Actually, sorry, that thing is, 3 inches. This is 6. And this is 3. Okay, so there is my geometry and exit. We're going to join it. And we put a material on it. So I think I'm assuming it's made out of steel with default properties. So there we are. Now I don't need an orientation point because the cross section is circular or tubular, and therefore it's unnecessary to put a orientation point. So now we're going to go to analysis and simulation. Generative structure analysis. Because there is no solid model here, CATIA will not mesh anything for you. You have to do that yourself. So here is the beam measure. You select that. And let me see now, this was 3 inches. So let me make this thing maybe 0.25. Actually 0.5 will do. 0.5 linear elements. Okay. And if you want to see the mesh, put the cursor there, right click mesh visualization. And there you can see that these are the type of the elements. Let me see what kind of element I'm using. I'm using linear. These are the 2 noded one we should find. And so these are the element and nodes, etc. Now deactivate this. Okay, so we meshed it. Now we specify the 1D property, in other words, the cross section of this. And notice that these two have the same cross section, but this one is different from that as far as the size goes. So I'm going to go to 1D property. What I will do, I'll put on this joint, all of it. I put on all 3 pieces, same cross section. And later on, I'm going to change this bottom one. So notice that the material, actually, I think I forgot to put the material. Maybe not. I'm not sure. Let me see if I put the material there. Yeah, the material is there. Okay, so let me do the following. It's already meshed. So 1D property on this geometry, your steel is picked. You can see that. So it says cylindrical beam. I'm going to change the radius to 0.1. 0.1. We say okay. So these three pieces all have, these three pieces all have the same cross section. Later on, I have to change this thing. But also notice that I can close this without any orientation point because it's circular in nature. Good. Now, when I go to property, I go to the property, put the cursor on 1D property, right click at the bottom, it's a local 1D property. You click on it and then you select this bottom piece, and there you can change the radius. So you click on the wrench, the radius, we're going to change it to 0.2. That's what the problem statement said. I think that's what it said. Yeah, these are 0.1 and this one radius 0.2. Very good. And we say, okay, very good. So now we're going to clamp this end. So clamp this end. And this point, let me hide these cross sections. Let me hide these. Okay, good. This point is on the XZ plane of symmetry. Okay, XZ plane of symmetry. In my case, is it XZ? Yeah, XZ plane of symmetry. So it does not move in the Y direction, and rotations is exactly the opposite. That point was clamped. That's good. And now we go to user define. And let me remind you, just so that I remember what I've done. This is for symmetry, just so that I remember. So this point does not move in the direction Y, and rotation is exactly the opposite. So this is for symmetry. Now I want to push this thing down by some amount. So let me actually hide this so that you can see it better. You get confused. So this is the restraint that I put. I'm going to hide this or hide it. Yeah, good. Now another one. I want to push this point down, right? Pushing down means that you want to first you have to make a zero downward displacement or upward displacement, zero. Oh, by the way, let me change also, call this thing pushing down. Pushing down. Okay, very good. And now we can change it using enforced displacement right here, enforced displacement, enforced displacement. You select that and you say downward displacement of 0.001, negative 0.001. Yep, that's good. It just happens to be the right value because that's what I did in a different problem. So just coincidentally, it happens to be correct. Okay, let's save our analysis file, save management, analysis, save as. That's in the right folder, morning activity, May 17, analysis. It's going to go there. And now we're going to run it. Okay, nothing magic is going to happen. This is just going to go downward, as you can see. Okay, that's how it's going to look like, and you can animate this thing if you want. That's how it's going to go. All right. Now, this was a previous midterm problem. So down here, that's the way it was marked. This is just to give you a rough idea. It doesn't mean that every problem is going to be like that on every midterm. But anyway, it says, what is the force needed to cause the deformation? So, and you have to write your answer in this box, okay? So what we're going to do is, first of all, deactivate this plot. The cursor there, right-click, deactivate. Good, instead of going to the tree. Good. Now, what we're going to do is we go to the bottom of tree, sensor, right-click, create resultant sensor, create reaction sensor, and from the screen, you select this pushing down icon, pushing down icon from the tree or from the screen, and you say update. So this says 0.469. So what you need to do, first of all, say okay, so that there's a record of it on the tree, so that when I can mark your answer, your problems, I know where you got it from. Okay, so it's right there. You can see that 0.469 pound force. Now, the number that you have to write down on your exam paper is not this, it has to be double of that, two times that. That's very important. If you just wrote down that 0.46, whatever you got, you're going to lose probably, you probably lost about 3 marks. Okay, so this has to be double of that because this thing that you're giving me is just to move the left side. You also need the same amount to move the right side. So you have to write two times whatever you got, zero point 0.4, blah, blah, blah. Okay, so this is the morning activity.